to be looking at average rate of change from several different types of graphs, including polynomial, trig, log, reciprocal, radical, and piecewise functions. So when we study rate of change, initially we study that as slope of a line. So just a little background here. We usually study slope when we first start out as the slope of a line, and then a line has what we call continuous and consistent slope. So slope and rate of change are you can take those words and use them back and forth. Average rate of change means slope, slope means average rate of change. So if we're talking about a line, another phrase that we use for average rate of change and slope is rise over run. So we count, rise over run to get from one point to another. If we go to another point, we use the same rise and the same run. Even if we went from this point to this point and did a rise over run, it would reduce to be the same as it was between the 2 points that are closest together. So we usually start by finding rate of change when we do linear equations. So we look at lines, but we're going to extend that thought and that phrase, average rate of change, to other types of graphs. So let's take a look at this quadratic function. And let's look at, if we're talking about, the left-hand side of this graph has a negative rate of change because it's decreasing. The right-hand side of this graph has a positive rate of change. So if a graph is not linear, then its rate of change can be different depending on where you're at on the graph. So they're going to have to ask you for an interval. So this says, find the rate of change in the interval from 0 to 3. So when x is 0, here's my point. So these are x values, okay? When x is 3, then my point is way up here at 7. So when a graph is not a straight line, when it's not linear, they're going to have to give you a section of the graph for you to calculate its slope. So if I were to calculate slope here, you could do it algebraically. You could also do it graphically. So it's rise. So this would be 1. So I'm going from 1 to 7. So its rise would be 6. And I'm going from 0 to 3. And its run would be 3. So remember, it's rise over run and then reduce. So my rate of change in the interval, from the interval where x is 0 to where x is 3, is 2. Okay, you can do this also algebraically. I'll just show you the algebraic part, and then the rest of my examples I'm going to do graphically. So if we're at 0, this point right here is 0, 1. So this point is 0, 1. If x is 3, this point is going to be 3, 7. And if we do it algebraically, we'll work that slope formula, which is your second y minus your first y, or the change in y, or your rise, over your change in x, which will be your second x minus your first x. So if we did it algebraically, it's going to be 7 minus 1 over 3 minus 0, which is going to give us 6 over 3, which is going to also give us 2. So we could do it algebraically. We could find the rate of change between 2 points. We could do it algebraically, or we could do it graphically. So on this first answer, I showed you graphically. I also showed you algebraically. The remaining of these I'm going to do graphically just because I want to get through several different types of graphs. So I'm going to show you graphically on the rest of these examples. All right, my second example is a trig graph. It could be sine or cosine. This is asking us to find the average rate of change from 0 to 1. So I'm going to locate this point. So when x is 0, it's this point. Where x is 1, it would be this point. So we're actually counting rise over run. So this, you could do it this way. It's 1 over 2. Even though that's not 1 unit, I think that's going to work. Rise over run. If we count the units, let's go back and think about this. This is 1. So this would really be 0.5, and then this would be over 1. So if you count the units, that's still going to give you 0.5, which is the same thing as 1/2. So when you're counting rise over run, just count the blocks. So up 1, over 2. Don't worry about the units because the answer's reduced to be the same thing each time. All right, so we looked at polynomial. We looked at a trig function. Let's look at another type of function. Let's look at a log function. This is asking us to find the rate of change from where x is 1 to where x is 10, because remember the rate of change is going to change depending on which 2 points that we're talking about, because this is not a linear graph, it's a logarithm. So we're going from where x is 1 to where x is 10. So again, we're going to count rise over run. So we're going to rise 2, and we're going to run, let's see, we're going to rise 2, and we're going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's going to be 2 over 18, which reduces to be 1/9. All right, let's look at our next example. It is a reciprocal graph. Whenever x, we've got our x in the bottom, and they're asking us to find the range from where x is 1 to where x is 2. So this is where x is 1. It's at this point. And this is where x is 2 is at this point. So this time I'm going to have a negative slope because my graph is going downhill. So my rise is going to be 1, but I'm going down. So that's going to make that a -1. And then I'm going over 2. So my slope's going to end up being -1/2 there. Quick reminder, if your graph is increasing, your slope's always positive. If it's decreasing, it's always negative. This particular function is a radical function. Sorry, lost it there for a minute. It's asking us to find the rate of change or the slope from where x is 0 to where x is 4. So here's where x is 0, here's where x is 4. So go up to this point. And then again, I'm going to count rise over run. So I'm going up 1, 2, 3, 4. Again, I know that's 2, but this works also as long as you count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So my slope is 4 over 8, which reduces to be 1/2. To me, it's just easier to count the squares and worry about what the scaling is, because this works both ways. And then our last example is a piecewise function. Again, I know it's a piecewise function because it's got this little, hey, I only want this graph where the piece is less than or equal to 1. It's asking us for the average rate of change between where x is -2. So find the point on the graph where x is -2. Find the point on the graph where x is 0. And then this is going downhill, so this slope will also be negative. So I'm going to count rise. So that's, if I count, you can count 4 here. Let's do 4 since it's marked. And then my run would be 2, and I'm going to the left, so that's -2. So my slope will be 4 over -2, which reduces to have a slope or rate of change of -2. All right, I'm going to point something out because I am not sure if I did this at the very beginning, but when you're finding these points, when you're going from 0 to 3, you're finding the point on the graph that has an x of 0. So that's that point. And then you're finding the point on the graph that has an x of 3. You got to find the 2 points on your graph that has these two x's value first. So again, the interval was 0 to 1. So you find the point on your graph that has an x of 0. You find the point on the graph that has an x of 1. And then you find the rise and the run from those 2 points. I want to make sure that I did that. That I said that and that was clear. Okay. Awesome. Hope you learned a little bit more about average rate of change from a range of graphs like polynomial, trig, logarithmic, reciprocal, radical, piecewise, and piecewise functions.